All right, today we're going to be working on the determining a point of an intersection to solve a problem. Serena's ordering lunch from Tony's Pizza Parlor. John told her that he ordered a couple pizzas and a couple of drinks and spent $34. Jody told her that she ordered one pizza and three drinks. It cost $23. What's the very first thing we need to do whenever we see a word problem? I need an answer. Okay, mark the text, right? $34 for two pizzas and two drinks. Good. What else? Whoops, not Serena. Okay, so I want to define my variables. Is that what you're saying? All right, so let X be what?
Cost of pizza.
Good. Why is it the cost of pizza and not cost of drinks? Yeah, the only reason is because the pizza comes up very first right here. Pizza, then drinks, pizza, then drinks. When we're talking about ordered pairs always follow a certain order, right? And because of this order right here, pizza, then drinks, that's the way we define this. X is the pizza, Y is the cost of drinks. Okay? If we're going to write our first equation, we're going to write an equation for John. John bought some pizza and he bought some drinks and it cost him $34. What am I missing from the equation?
How many?
Two pizzas and two drinks. Thank you. Good. So now we need another equation to talk about Jody. Jody bought how many pizzas? Just one. There you go. And how many drinks? And what did it cost her?
$23.
There you go. Now we have a system of equations. Cool thing is now with this system, I can have them work together to be able to figure out how much a pizza is and how much a drink is. Okay? The way I want to do that is through substitution. Do you see any variables that are already completely by themselves? Is it completely by itself or is it sort of by itself? So X is sort of by itself right here, right? Let's get it completely by itself. And then the thing that we're going to do when we do this, well, we'll just do this like we normally would. How do I get X by itself right here? Well, we want to get rid of the 3 times Y, right? That's eliminated. And that gives me X is equal to 23 minus 3 times Y. Now let's actually talk about this knowing what the variable means. What is X?
X is cost of the pizza.
Cost of a pizza, right? So now if I read this, I can say the cost of the pizza was $23 minus the cost of 3 drinks. Does that make sense? If we're talking about the cost of the pizza, if I take away the cost of the drinks, then I know the cost of the pizza, right? And now the cool thing is I can take John's equation because it's a system and I can make these two equations work together. John's equation is 2 times X plus 2 times Y equals 34. And I know that the cost of one pizza is $23 minus $3 for drink or $3 or 3 drinks. So I can take that and substitute it right in for X. And what becomes cool about that is she got 2 pizzas, which are $23. Excuse me. John got 2 pizzas, which was $23 minus 3 drinks, plus his 2 drinks is equal to 34. And then look what I have left to find. Just the cost of the drinks, right? I've eliminated, for right now, the cost of the pizza. I've actually embedded the cost of the pizza to be able to find the cost of the drinks. And now I end up with this, $46 minus $6 in drinks plus $2 in drinks is equal to $34. I take away the 46, so I'm combining terms using properties of equality. And then I'll combine like terms. Negative 4 times Y, 34 minus 46 is negative 12. And then I divide to find out that each drink costs $3. Get that copied down real quick. And while you're copying that down, problem number 2 says interpret what the point of intersection means. What I think right now is that the intersection has a y coordinate of 3. I think the cost of drinks is $3. We're going to find out here in a minute, though. Okay, that's the first part. Now I need to find out the cost of a pizza, right? I think that between these two equations, Jody's equation is going to be a lot easier to find out the cost of one pizza because it's already set up with one pizza. And so I go back to the original equation and I say one pizza plus 3 drinks, and each of those drinks are $3 a piece, is equal to $23. So that means that a pizza plus $9 was $23. Subtract the $9 from the total, and one pizza is equal to 14 bucks. I think that my order pair is 14 and 3. How do I verify that, though? Substitute it where?
On the graph.
Not on the graph.
Substitute it for F.
I already worked with Jody's equation, right? Let's work with John's equation now. We already know this works for Jody's equation because I know 14 plus 9 is 23, right? That's a true statement. Okay? Let's substitute for John's. $2 per pizza, or 2 pizzas at $14, 2 drinks at $3 equals $34. So that's 28 plus 6 equals 34. And that's a true statement. And I know for a fact that my intersection is correct. Those two lines, when we draw them, would intersect. Well, I already had these on here before, so I'm just going to copy down what I had before. If I already graphed these two lines, here's what I would see. I would have a line. Oh my goodness, I'm struggling today. It goes right here. And that would be either, all of the money would be either 17.17, and over here, the other line would intersect right here. And we would actually see that point right there is 14 and 3. Now, here's the reason why I don't really care about the graph. Because algebraically, I already proved that I'm right with these two. And so what that means now is the very last thing I want to make on here is understanding this. Let's interpret that ordered pair. What does it mean? One pizza cost what?
$14.
$14. One drink cost what?
$3.
And that's it.